seems the temperature is quite suitable for sleep. So I try to open the air conditioners so that I have some of the fresh airs inside. Okay, so let's continue. Okay, so from the key questions in hydrogeological investigations, the upper part will be provided by AI and lower part is provided by me. So that's also one of the points that I would like to raise. When you try to answer the questions for the midterm exam, I also hope you can do similar work. I will try to think about what kind of questions can provide you to ask an AI system. Okay, you can use in AI, but maybe you can try different kinds of AI versions, different kind of AI LLM, like ChatGPT or Gemini or others. You can try different kind of AI system to answer the questions and see the differences or what the answers, and you will be able to provide like make up extra conditions or even some of the part they might not be totally correct, or some of that content may have the repeat conditions. So you will be able to do some corrections or do some update and then revise your answer. And remember that for these kind of answers, this time you need to put both the AI answer and your answers or your corrections together. I hope you can use an AI system to help you clarify some of the concept, and then you can provide your own opinions. And they'll be better, or how to properly use an AI system to help your learnings. I think that's a very important point in the recent years. Because AI cannot avoid, I think all of you know that, and that's very useful. But it seems some of the content might not totally correct, or some of the content might not complete, because it's only able to learn the old concept. And if you ask it to provide some of the novelty or some of the new ideas, could be okay, but maybe not so powerful. So try to use an AI to help you find out some of the solution or some of the answer for your questions. Okay, like that. Yeah, so if we would like to assess more like engineering or the hazards issues, you might need to have more information to get this insight. And that's only for the water part. And how about the solid part? So hydrogeological material distributions, as we mentioned, the first part, it affects quite largely for your assessment. And fracture orientation is also another issue. Although we do not talking here, that's due to the fracture systems and the rock systems. There will be larger differences compared to the previous one. But as I mentioned, that for hydroconductivity, we can use in the tensors concept, or can use in much complex anisotropic system for the assessment. For the sedimentary system, they'll be easy. Commonly, we assume Ks, Ky is the same, and we use in the anisotropic for the vertical direction. But for the fracture system, we might need to have Ks, Ky, Kz to be differences, and they will be able to assess from orientation, also from the fracture. Like when you have a fracture, you need to consider the fracture density. You need to consider the fracture length or the opening systems, and you also need to consider a lot of the angles issues together. So they'll be much complex. And if you like to use in the traditional concept like Artesian coordinate systems, you need to have some of the tensor calculation or principal directions concept, and they'll be really complex for this part. Yeah, but that's very important part for the engineering work for the deeper geological system for that. Okay, and the hydrogeological investigation workflow could be separated to this part. The first that you need to define your problems. So every project or any work when you obtain from like maybe your advisors, they should have some of the main problems want to solve. or what's the key point you want to solve. So you need to understand what could be your problems. So state the problem is very important, or define the problem is very important. And this is the key. For example, for the master students, you commonly got the topic from your advisors. But for the PhD students, you need to find out what could be the problems. Okay. Masters is professor give you problems, you solve that. And PhD, you need to find the problem and solve that. Okay. So how to find out the problems is the key. So most of the project work or your master thesis could be you already have the problems. But sometimes you might misunderstanding your advisor's problems. So you need to continue to discuss with him what's the really key problems you want to solve. And then you will be able to focus on that and to solve that. Okay, so the very important part. How to clearly define your problem is very important, and also for a research part. And then you can develop conceptual models or your kind of plan. Because if you have the problems there, you will have you can imagine what could be the whole concept, what's the whole structure for your problems. And then you can imagine what's the possible step to reach the solutions. So that's a kind of plan, okay? Or we can say there's a kind of conceptual model, conceptual concept. So after you have problems, you need to have the plan, like a kind of proposal. You're writing proposals. How to achieve that problems or how to solve that problems. You have the several steps. So there's a kind of conceptual models. And then after that, you try to step by step to reach that. Okay, so you have to conduct the field investigations. Or for hydrogeological survey would be you have the problems you want to solve, and then you collect the data, collect the basic information, basic map. And then you can have your concept, and then go to the field to do the investigations. Like you might imagine, oh, this one, they might have the clay layers, or they might have some of the weak like a fracture or the fault layers. You imagine that from the surface or from the map, you imagine they will have the fault. Like if you want to find a geothermal system, you need to find out there could be a potential normal fault or strike slip fault. They might be the flow path for the geothermal system. And then you try to go to the field to do the drillings to confirm if they match your expectation. Okay. So let's try to conduct the field investigations. Or some of the place you might feel, this is not clear, so I need to go to the field to take a look if this place is really like your imaginations. Okay, go to some of the place to take a look at the conditions. So traditional geologists, they commonly have their images on their brain. And then they go to the field to prove or to find the evidence to support their thinkings. If they find evidence, that's good, because that means that his thinking is correct. But if not, okay, he can collect the data and go back to reconstruct their concept, their conceptual models. Okay, conceptual model. They can go to the field to confirm, but if no, they need to go back to modify, to update their conceptual models, and iteratively, and you will be able to gather more precisely the models. We call it geological model or hydrogeological model. Okay. And after you have this kind of result, you might set up, you can have the data collect back to do the analysis. And some of that you will put on some of the observation system there to do the observations, to do the survey. There could be the time-dependent, time series analysis. And they have different locations, so they have the spatial temporal variations. So you'll be able to do the data analysis. Okay. This part could be solid, this part could be the soft, fluid, or the solid data and soft data like that. And then you can combine them together to see if you can solve the problems. Okay. Apply your results and go back to see if you can solve the problem or not. Like if you like to find out where could be the geothermal reservoir, okay? You want to find one geothermal reservoir, how to do the drillings to reach the reservoir or to reach the potential areas. and you have the conceptual model, you have the geological structures, you have the geological map, and then you know the orientation of the fault, you might be able to have the plan to drilling the borehole, how long the depth you need to reach the system. And then you take the sample, also need to go back to do some assessment, or using the field test to do some assessments. And then you can take the sample to analyze the hydraulic conductivity, how large are K values, or the fracture system, if they have the fracture area, or they have the seal system, or have the fault gauge, or some others, okay? And then you can combine them together. Even you can use numerical models to prove if the concept is workable or not. And then you can try to confirm if this drilling or this survey is able to provide you the hot waters, the high temperature waters or not. Okay, and following will be some different kind of data. So there will be geological data, although geological data could be quite largely differences. Like we might have the lithology or stratigraphic. And lithology is, later we can have some of the information, further information. And structural features and sediment characteristic. And some of that you might not able to directly link to the hydrogeology, but most of the geologic conditions also affect the hydrogeological conditions. Okay, so let's take a look. Lithology is of the rock unit is a description of its physical characteristic visible at outcrop in hand or core samples or with low magnifications microscopy. So you can use in the institutes using your eyes to take a look at the outscope, and you can take the core sample. You can drill in the core sample to take a look, and also you can take back to the lab to do some experiment, or using the microscope to take a look at the fine-grained materials like that. And the physical characteristics include the colors, texture, grain size, and also composition. And color, sometimes they connect to the weathering or connect to the chemical component. And textures or grain size, they could be affected like the fluid behaviors. What kind of textures or what kind of grain size might easier to have the fluid to transport. Like if the composition is mainly for the gravels, they will easy to have the fluid penetrate. And if they are like the shield, they are not easy to have the water to flow through. So you'll be able to identify that. And lithology may refer to either a detailed description of those characteristics or a summary of the gross physical characteristic of the rock. Okay, so lithology is the background information. For example, example of the lithology in the second sense include the sandstone, slate, basalt, or the limestone. Okay, so this is try to define what kind of material you obtained. They could belong to the sedimentary rock or the other igneous rock or the others. Okay, metamorphic rock like that. So lithology commonly is still meaning for the geology, but some of that provide the background information for if they are able to transmit waters, like sandstone, they were able to have the water transmissions. But the shale is not, or slate will be not so easy to have the water flow. Basalt also, but some of that have the fractures. And limestone, they were easy to have the erosions like that. And they might also have some of the chemical reactions ability. So some of the background information might be able to provide you the water transmit or the water quality informations, and you will have some background concept for that. And stratigraphy is a branch of the geology concerned with the study of the rock layers, strata, and also the layering, like stratifications. So stratigraphy is try to identify like layer systems, formations. We commonly using formations. What kind of formations? And they will belong to, commonly could be the same years or the same period of the years. Okay, this edge is concept. It is primarily used in the study of the sedimentary and also the layered volcano rock. And stratigraphic have three relative subfields, like lithostratigraphic, biostratigraphic, and coronstratigraphic. Okay, so one of them is the edges, one of them is a biologist, one of them is lithologists. Okay, so they could be also have different kind of discipline field. And honestly speaking, I'm not this background, so I cannot understand too much of the detail connect to the hydrogeology. But some of that will be able to connect. Like commonly stratigraphic interface is the beddings, and we will be able to find out there could be a kind of weak point. They might able to have some of the flow path inside. Okay. Yeah, but there's a relative deeper for the geology system, not for the sedimentary systems. And geological structure features. Geological structure features are specific arrangement of the rock layers and the deformation product, include the faults, joint, foliations, and unconformity caused by tectonic straits. This is belong to the geology. I don't know if you have background for geology, as most of you have that. So you will be able to know what's the meaning for that. And commonly, we know that the formations deposit for the horizontal directions is meaning for the horizontal orientations. But if you have some of the tectonic straits or you have some trace conditions in the formations, you might have some bendings or you might have some of the disturbances for your formations. So they will induce the faults, joint and foliations is another. Okay, these two is mainly for the tectonic conditions. And unconformity is not due to the tectonic, but it is the formations. How to say? They have erosions, the weathering together. Okay, and joint and foliations is mainly for the inner stress conditions. So they induce some of the channels for the water to float. Okay. So commonly, the joint or the foliations, they become like a preferential flow path. So although they are in a rock system, but that kind of fractures will able to have the water flow through. So that's what we call the previous part is the fractures. So there could be different kind of definitions. And fault and these two faults, they were able to have become like a anticline or syncline. They were able to have the water storage or like oil and gas storage reservoirs. Okay, there could be like a CO system. If you have to install the CO2, you need to find the anticline system, and they will be able to have the gas to be stored there. And the fault will be the preferential flow path. Although the fault, they have the much complex conditions. Commonly, we might say the four cores, the two rocks, if they would have the relative movement, the central part will be the fault gouge. The fault gouge is mainly for the very fine-grained material like clay. So they become the impermeable materials. And then away from the fault gouge, they will have some damage zone. We call it damage zone. Because the original entire rock, when they have the relative move, they have the damage. So the damaged part will become high fracture areas, or the damaged area. They become the high permeability areas. So in the fault systems, they can include both of the impermeable and high permeable materials together. Okay, that quite depends. So some of the fault you might be able to find the fault gouge. They become impermeable in the central, but their lateral part will be high permeable areas. But some fault they do not have the fault gouge. They just have the damage zone. So that quite depends on the condition. So if you have the fault, you need to try to collect some of the information like the core sample to take a look if they have the fault gouge and what's the damage conditions. And even you might be able to do some of the experiment to identify the K value, but honestly speaking, it's not easy. Because when you have a fault system, you do the pumping test, you will meet another problems because they become like barriers. Okay, so the pumping test is also not easy to conduct around the fault. And these features ranges from microscope crystal to the massive mountain ranges, reveal the deformation history of the Earth's crust. Okay, so this is also another difficulty. For some of the conditions, when we're talking about the groundwater systems, although we commonly use in the microscope point of view to see, like we use in the Darcy's law concept, we use in a relatively larger scale to see the whole behaviors. But when we doing some assessment, we also found that the refiner's microscope point of view affect quite largely for your behaviors. For example, clay. Clay is not able to see from the outside, but if we zoom into the inside, we'll see that the clay have the structures very tiny, so they affect the groundwater to float. Okay. If we use in a larger scope point of view, we might think, oh, this material, they have high porosity. They might be able to have the high flow behaviors. High porosity have the easy to have the flow. It's common sense, right? But the material is the clay, so they become the fine-grained materials. They become impermeable materials. So they become the microscope concept. Okay. Although we know that, but from the previous, maybe researchers don't know. They need to understand why it is impermeable, although they have high porosity for that. And another could be like the bound conditions. Some of the water, like we mentioned, they have some residual waters not able to be totally drained out. There's also the microscope point of view. They have some chemical bond to attract the waters. They become a film on the surface. Okay, and that's not easy to use in a microscope concept. You need to zoom in, and you will be able to know what's the really problems there. Although it do not affect very huge the huge behaviors, but they still affect a part of the result. Okay, like when you consider the chemical transportations, the through transport, this kind of behavior affect largely. Okay, so yeah, so that quite depends. Although we use a microscope to overall describing the behavior, but the microscope concept sometimes it still affect quite largely. So how to understand from the microscope to the microscope is also not easy. The primary structure, like a bending form during depositions, while secondary structures result from deformation. Okay, so primary structures is mainly for the deposit processes, and the secondary structure is due to the tectonic or due to some other outside stress conditions. So we have the inner and outside stress conditions to affect the structure. So some of the major type of the geological structure fault, bend or rip in layers rock caused by compression force, including anticline and syncline, and also monoclines. Okay, so if you're interested, you can try to search by yourself or try to find the information by yourself. And this kind of system I mentioned, some of that will be easy to collect waters or to become a CO system. Okay, like the oil gas reservoir or a CO2 sequestration system. And the fault, fractures in rock where displacement or sliding was occurred, and classified by movement as normal or reverse normal fault, reverse fault, or structural fault. So they are exerted by the tensions or the compression or the shear conditions. And joint is fractures in rock where no significant displacement has occurred. They are brittle values often occur in set. Okay, so joint commonly have the set, like we might have 2 set or 3 set of the joint. And the set means they are not just one line. They have a lot of line in that area. Okay, so if you ever take the geology course, you might know that. Okay, yeah, some of the definition for this for your reference. And as I mentioned, these severals could be, fault could be the provincial flow path, and the joint is the same. They could be the many, in the rock system, the water is mainly occupied in the fault or in the joint. For reactions, preferred orientation of the mineral grains in metamorphic rock often formed under high pressures. Okay, So foliation is mainly for the metamorphic rock. Okay. Metamorphic rock. Okay. We use that to define like a kind of a layer concept. Okay, although it's not exactly the layer, but it is we call it foliation. Okay, and that could be the relative weak point. If you have some of the trace, they might easy to have some of the broken maybe. Okay, yeah, but there are many for the high pressures to induce this kind of foliation. And unconformities, surface of the erosion or non-deposition that separate young rock from the old rock, representing a gap in the geological records. So commonly there will be the continuously layer system if we only have deposit. But sometimes we have deposit, but we might have erosions and then have another deposit. So they have become unconformative. Okay, we call it unconformative. Yeah, so they will become like that. And since this kind of condition, maybe they are not so stick because they are also kind of interface, still kind of interface. They will be a possible flow channels. And primary structures, the features formed during the creation of the rock itself, such as the marine beddings, laminate or the lava pillows in the volcanic rock. Okay, so commonly when we have the sediments, we have the beddings or like a kind of layer systems. Okay, yeah, all of that could be affect the groundwater flow. And yeah, right now here we do not talking about too much about the different environment. As we mentioned previously, when we have the transgression and regressions, we have the like a continent deposit or the marine deposit or the lake deposit. So the deposition material will be different. And if you have the river channels commonly the material could be relative coarse materials. So the river channel commonly they become a kind of a preferential flow path for the groundwater to transmit. And the key aspect of the geological structural geology, the stress and strain. The structure are the result of strain deformations caused by stress. There's a force per unit area, which is with ductile deformations cause fault, and also the brittle deformation cause the fault. So there could be like a soft condition or the very brittle condition or the relative rigid condition. So they will induce the fault or faults. Okay, so there will be different result. And like in another class, I mentioned that if you have waters inside, you might able to have relative soft result. And the orientations, we commonly use the dip and strike. Geologists measures the orientation of the planars, joint, fault, beddings, and linear structures in the field to mapping underground structures. Yeah, so although we commonly able to see it on the surface, so we go to the field to take a look at the outscope and try to identify or try to do some measurement for the joint beddings and even the fault. And we will be able to connect them to the deeper systems. We will be able to assess or to infer where could be the major rock system or where could be the major channel for the water to fluid. Okay. And we use in a strike and dip to do the measurement. So I think geological students should know that. And engineering applications, understanding joint, fault, and foliation is critical for assessing the stability of the slope, tunnels, and also the dam foundations. Okay, yeah. So there's also some of the basic. So we have the applied geology is meaning to do this kind of work. We base on that kind of geology structure or geological concept connect to the engineering work. And also remember that for the engineering work, it's not easy to remove the waters. Groundwater always play a very important role in the engineering work. Okay, they will that your engineering work damage or become broken. So be careful for groundwater system. And besides the geological features, and we also go into the sedimentary characteristic. And sediment characteristics refer to the physical, chemical, and biological property of the particle. ranging from fine clay to boulders that define their transport, deposit, and environmental impact. Okay, so for traditional hydrogeology, we are mainly talking about sediments. They are most of them are unconsolidated materials, so they are relatively loose materials, and they were able to occupy much more waters inside. Okay, so yeah, mainly for the water resources, if we talking about traditional hydrogeology. And the key characteristic include grain size, affect the your porosity or permeability, the shape. Although in traditional hydrogeology, we do not talking about this too much, roughness, roundness, or the angularity. But what am I familiar with that? We talking about the Georgia River Alluvia fan. Although they have the sand materials, but they still have high compressibilities in the aquifer system. The grain size is large because they belong to sand. Okay, the grain size is large, but their shape is like a plant. So when they deposit there, they are easy to construct like a space. If they arbitrarily distribute it, they will create a lot of spaces. But after you have the pumping, you have some disturbances for your groundwater systems. This kind of the sand particles, they are easy to be compressed. And after they be compressed, they will not go back because they are not rounded. Okay, they have their orientation. They become like a kind of pieces. So they become not look like the elastic or the traditional sand concept or the gravel concept. So this will be affected by their shape. Their shape will affect your hydraulic conductivity or affect your compressibility ability. And compositions, what kind of minerals or what kind of organic, if you have organic, they might be like a aerobic system, they might be, degraded due to the biological influences. So the organic also play quite important role. Like I forgot exactly the term. The peat, P-E-A-T. Yeah, some of the a specific kind of the materials, they are easy to have some of the the many compound of the organic. So like in the Netherlands, they have these problems. So they subsided quite significantly, but they are due to the organic issues, not due to the pumpings induced the compressions. Okay, so they are the perdent, maybe perdent. I forgot exactly, or pedant. Okay, maybe pedant. Okay, so they are organic. So if you have organic, they also have others, and organic materials inside also have relative. They might not easy to have the water to flow through it. Okay, they have other influences together, and that's the effect the gravity, like a kind of gravity, which influences like porosity, permeability, and also the contaminant beating capacity. Yeah, so these several properties will also affect your porosity and permeability, and also some of chemicals interactions behaviors. Yeah, so sediment systems also quite complex, but honestly speaking, as we mentioned, that from the very fine system to the relative coarse, like a boulder, so sometimes it's not easy to combine them together for totally understand that. So we're still able to use in the empirical concept, not the physical concept, to describing all the behaviors. The grain size and sortings determine the mobilities. Fine sediments stay suspended, and while coarse sediments like gravel and sand form the bed load. Sorting describing the uniformity of the grain size. Okay, so sortings and another is grading is the difference. Sorting is commonly used for the earth science. So where sortings means the particle is more uniform distributed. Okay, and gradings in the civil engineering means that they have gradings means they have the different kind of distribution, different kind of particle distributions. Okay. Because when in the civil engineering, when we're talking about grain size distributions, we considering if the soil able to support the buildings. So if they have the different kind of particle size, their pore spaces will be small, and then their strength will be strong. Okay, so they become better. Okay, so in civil engineering, commonly we were using the gratings, where gratings means they have different kind of particle size, but the sortings means that they are more uniform. Okay, where sortings means they are more uniform particles like that. So there will be real differences. And particle shape and textures ranges from angular to rounded, affecting how particles pack together and interact with water flow. Okay, yeah, I forgot one of that. Angular and round will also have different behaviors. When you put a different kind of particles together, if they are rounded, they will be more easier to become elastic when you put the trace. But if they are angular, that means they have some of the small pieces, right? And when you put the trace, they might easy to be broken. The small pieces might easy to broken. So the particle will easier to be distributed, and the pore spaces will easy to be compressed. So relative angular particles will induce the not impermeable. It's easy to induce the permanent deformations. They will have another deformation. They cannot go back because they will already damaged. Okay, the small pieces will damage, so they be removed. They become small pieces, so you will not go back. And if they are elastic, means you have two particles stick together, so they just push and then release, push and release, so they become elastic. But if you have angulars, that will broken, so they will change their shape, and they will not go back, so they become inelastic. Okay, so be careful for these issues. Yeah, although as I mentioned, they go into the microscope point of view, not the macroscope point of view. So sometimes it's not easy. And compositions derived from rock, these integrations like the lithogenous and organism remains biogenous or chemical precipitations, hydrogenous, and also there's common components include quartz, clay, and also the calcium carbonate. So that could be from traditional concept like a lithology concept or some of the bio or some chemicals together. So they'll be really complex. And the physical properties include porosity. We know that pore spaces, permeability, free flow capacity, which detect water infiltrations. For the physical way, commonly is really simplified. I forgot to mention that. For the chemical part, or the chemical part here, okay, chemical part, when we have the chemical reactions, they will let your system much complex. For example, like CO2 sequestrations, we put the CO2 into the deep depths, and then CO2 might transfer to the rock. They become like the calcium carbonate systems. They might become the rock, the limestone, or the others. They change the format. So originally they are the fluid or even a gas, okay, like liquid or gas. But after they change to the rock system, they will seal the original pore spaces. So your original pore spaces is able to have the fluid to transmit. But after you have the chemical reactions, they might cease your pore spaces, cease your original channels. So they become impermeable or less permeable. Okay, so they will change your properties for that. That's the much complex part. And if you would like to simulate these kind of behaviors, it's also it's much more complex because you need to consider the chemical reactions inside. And then your simulations, originally is the pore spaces, but right now they become the solid phases. So your solid mass increase and your free mass decrease. So you also need to calculate the exchange. For example, commonly when we're doing the groundwater assessment, we're using the mass conservation, free mass conservation. That means your free do not change. The mass will not change. Okay, but when your free mass will change to the solid, and your solid also increase the mass. So your total system is totally changed. You cannot use the mass conservation anymore from the free part. Okay, so that will be very, very complex. Just that you understand that. So the chemical part affect quite largely for your water flow system. Although in traditional hydrogeology, we ignore the chemical reaction, or we ignore like the precipitations concept, because they become very complex. Okay, and chemical environmental state define whether sediments are acidic or anacidic, and which affect organic matters decomposition, and also the binding of the contaminant like the metal or the PCBs. Yeah, I'm not sure here. I forgot to put the full names inside. Yeah, but I still not understand this what's the exactly content here. Yeah, so if you have the chemical inside, they will be really complex. As I mentioned, if you have acidic or anacidic conditions, or sometimes the oxidations or not reaction, or I forgot exactly the term, how to pronounce that. As I mentioned, they might release the arsenic. Okay, originally they are not toxic, but right now they become toxic to affect your environmental problems, induce the environmental problem for that. So the sediments have the different kind of properties. They could be affect, or they have the play the role to influences the water flow system. Yeah, although sometimes, as I mentioned, from the macroscope to the microscope, it's not easy. But most of the conditions for the groundwater hydrology, we use the macroscope point of view. We do not consider to finest material property. And the environmental significance of the sediments. The sediments are crucial for habitat integrity, sorting contaminant, and also the recording the geological history. They are classified into lithologies, hydrogenous and biogenous, and also the cosmogenous type based on their origins. Sedimentation structures such as the bedding, ripple mark, and fossils provide insight into the past deposition environment. Speaking, this kind of historical system, the past depositional environments, or we call sedimentary systems, they'll be quite complex. And although they are not easy to understand, but they provide the very important background information for the past, we call it paleo climate conditions. And they will be able to let you understand the past and then how to connect to the recent like that. Yeah, some of that is directly connected to hydrogeology, but some of that might not be so important. Yeah, but commonly when we're talking about hydrogeology, we do not consider too much about the chemical reactions part. Although we still put the chemicals inside, but the chemicals in meaningful like quality, water qualities. What kind of ions inside? And do they have any contaminations, compositions or not? Heavy metals, or they have the chlorides, or they have some others compounds inside to affect the drinking or the irrigation. Okay, so they could be like that. But most of the conditions, although we can have more complete, but they're not easy to include all of that together. And for the previous part is the geological data or hydrogeological data that we try to collect or try to understand. So when you're doing the hydrogeological survey, you might able to find out all of the components. But that depends not only on the target, but also on your budget. Because we do not able to figure out all of the contents. Okay. We might just focus on the key point or key components that affect your main target. For example, you want to understand the groundwater resources. You don't need to investigate all of the contents. You can provide just the background or overall macroscope concept is sufficient. But if your target is the subsidence, maybe you need to have more finer investigations, like your current material will be the important part to be compressed. Okay, so you need to understand how the clay distributed. And if you would like to assess the liquefactions, you need to understand the fine-grained material distributed. Like there could be the fine sand, where could be the high fine sand area, and where is the depth. Okay, because the depth also connect to the groundwater system, they were able to be liquefied, and you'll be able to assess that. So that's some of the background for geology. And after that will be the hydraulic data or hydrogeology data. Okay, yeah, although we use the AI provide the hydraulic data. And originally, the hydraulic data it provides very few, so I try to put more complete content. And honestly speaking, when we're talking about hydrogeology, we only focusing on the groundwater system. But I hope you can understand that when we're doing the groundwaters, we cannot avoid the climate to the surface. Because the water cycles connect together, you are not able to cut. Okay, you are not able to directly cut and then separate. We ignore that and just consider this. Yeah, although there could be the component, one of the components to the groundwater system. If we only take a look at the groundwater system, they become like a box. So we have the output, we have the in, and we have the out. So if we totally ignore this kind of input, I think it's maybe okay, but you need to understand how it input to your system, how it output the system. Okay, they'll be more complete to understand the totally groundwaters. Okay, so I stay here. The first part is the climate. So although commonly in the groundwater system, we might only consider the rainfall or precipitations. We have the waters infiltrate, or we have waters touch the ground surface, and then they have infiltration and they recharge. And commonly, we only assess the recharge quantities. Okay, but that could be a very important part. You need to understand the distribution of the rainfall because they affected your recharge amount. Okay, for example, the proximal fan commonly have high rainfall quantities, and distal fan have the less rainfall quantities. So you know your original source is different. And then you need to consider your surface, like your land use. Right now I do not put land use because there's a hydraulic. Okay, they have other inferences. The land use, if you are urban area, you might not easy to have infiltrations. But if you are like the lands, the grass or the forest, they might have the infiltrations. But some places have the strong transpirations. Okay. So you need to understand the land use, and then you'll be able to assess the suitable recharge quantity in your system. And then the surface part right now is the hydrology data because we have the surface water. We have the river, we have the lake, we have the pond. They affect your system, your groundwater system. So you need to understand what kind of the waters on the surface will have the recharge ability to your groundwater system. Like we see a lot of pond in Taiwan area, Taiwan cities. But you need to understand pond commonly they have the seal systems. They prevent the water to infiltrate. They have the clay between. So the pond look like they might have the infiltration to the groundwater system, maybe. But honestly speaking, maybe not so large. They could be few. And like a potty farm, you might feel that, oh, there's a lot of waters there on the surface, so they might have the strong infiltration to the groundwater system. But for reality, it's not. Okay, because they also have the clay layer system to prevent the water infiltrations. Because they want to keep the water on the surface to have the flat conditions. Okay, so commonly they also have the clay below, so the infiltration is not strong, although they have a lot of waters there. So sometimes you need to understand the condition for this kind of surface water system, and then you'll be able to connect to your groundwater system. Okay, now we take 10 minutes break.